Question 31. Okay, in this case, you were told that the metal rod, okay, and you want to charge it up with a cloth rubbing it, and you are holding it on your hand. Okay, so what happened is that let's look at all four options. Okay, so option A, it says that the charges on the cloth is neutralized by the opposite charge on the rod. So initially the rod does not carry any charge, so it is not possible for it to neutralize anything because the rod is neutral. Okay, look, let us jump to option C. Option C says that the metal rod can only be charged by induction. Well, you can charge it by rubbing as well, but definitely you cannot hold it with your hand because you yourself is conducting. You are like the earth to the metal rod. So even if you somehow manage to pass extra electron or take away extra electron from the metal rod using rubbing, you cannot hold it, because once you hold it, you are basically earthing it. The metal rod does not carry any charge. That is wrong. They carry charges. The metal rod carry charges, just that there are equal positive charge and equal number of negative charge. They still carry charge. Okay, just that it's equal. The number of positive charge and negative charge are equal. Okay, so let's look at option B. The excess charge produced on the rod are leaked through the hand. I think by leaked through the hand, they are actually saying that your hand is earthing the metal rod. So that's the reason. Okay, that is the reason why you are failing in charging it. Okay, for question 32. Question 32 is a potential divider. So first you need to recognize that actually the bulb and this 80 ohm resistor are connected in parallel. Okay, if it is connected in parallel, basically they are connected in series. Sorry, they're connected in series. So when they are connected in series, the EMF, the 6 volt, is going to be shared among these two. Okay, for example, you can visualize it in this way. Okay, you have, this is like the bar of EMF. So this entire bar of EMF is 6 volt. And because these two components are connected in series, part of the EMF will be used up by the 80 ohm resistor, and part of it will be used by the lamp. So essentially what they are saying is that now that the part used up by the lamp is 2 volt, you are to find out the ratio between this. So it is pretty simple. You can just write out a mathematical expression. The EMF is divided into 80 plus R part, because I do not know the resistance of this lamp, so I treat it as R. And out of these many parts, our number of parts is going to be taken up by the lamp. So, and you know that eventually this thing will give you 2, because 2 volt out of 6 volt is being used up by the lamp. So hence, by solving this equation, you get R equals to 40. Okay, for question 33 is your practical electricity. You need to know that the live wire is always connected to the fuse, and the live wire is the brown one. So this one is not the brown one, so this is out. This one is not the brown wire, this is out. Only C and D. The brown wire, which is the live wire, is connected to the fuse. Now the other thing is that the earth wire must be connected to the longest pin of the plug, so that the earth wire will be engaged before the live wire gets engaged. So therefore your earth wire is indicated by the green and yellow strip wire. So this is the one, this will be the longest pin, and therefore D is the correct plug, correct configuration. Okay, for question 34, you need to be very careful and really analyze it in terms of a circuit. Okay, so for the beginning, imagine that there is no break. Okay, imagine that there's no break. The circuit will look like you have a main supply going into a continuous wire. So if this and this are connected, it will be like this resistance is connected in series with this resistance. So imagine that now I break it up right in the center, right by half. So I will have like one resistor linked to another resistor like that. And if I want to find out the current in this circuit, I will just take V equals to IR. So I rearrange the formula, so the main current, okay, before the breakage will be equals to half of the main supply over the total the resistance of the wire. Now notice that when the wire is not broken, I name it R. Okay, so eventually use P equals to VI. So this is the power, the O power is equals to the voltage times the current of the whole circuit. You will get half V square over R. Okay, now when the wire breaks and the owner, is it who is doing that, and the engineer or whatever decided to patch it up by short circuiting it, essentially what you are doing is that your effective resistance here is actually 1R, but the O1 is 2R. So anyway, let's calculate the main current in the new configuration. So I new will be equals to just V over R. Okay, because this resistor will be short circuited by the wire, by this wire. Okay, so put it into the power formula. The new power will be equals to V, which is the supply, multiplied by the new current. So you get V square over now. So now if you compare between the O and the new, you see that the new is actually double the O1, because the O1 is half, the new one is one whole. So the new one is twice the amount of the O1. So therefore you get twice the power, part C, option C. Okay, question 35. Question 35 requires you to know that for an LDR, the resistance will actually decrease when the light intensity shining on it increases. So if you look at option A and B, when the LDR is covered, okay, so the light intensity will decrease and therefore the resistance here will increase. And if you look at this configuration, so this is like a potential divider, this and this is connected in series. So what happens is that when you cover the LDR, basically you are increasing the resistance here, and if you increase the resistance here, it's going to take a bigger share from the EMF. And if this guy get a bigger EMF share, this guy here will get a lesser EMF share, and this will make your bulb dimmer. So you already know that A and B is wrong. Now if you look at C and D, you are shining light on, when it says is incident on the LDR, basically they are trying to say that the light is being shined on the LDR. So when you shine light on the LDR, you are decreasing the resistance, and when you decrease the resistance, you are decreasing the share of EMF that this guy is getting, meaning that there will be a larger share here. So you know that these two will give you a brighter light. Now let us look at the second part. Now when you are moving this tip towards X, you are increasing the length of this resistor. So if you go and move this tip to the X, you are actually increasing the resistance here, and when you increase the resistance here, you're going to get a bigger share of this EMF. So when you get a bigger share, you will get a brighter bulb. So therefore, D is correct.